Greetings, ladies and gentlemen. Hope you are doing well. This is TJ's Maths and Further Maths Adventures. In today's presentation, we continue with our solutions to NECO 2024, and this is Further Mathematics. With us here is question 2. The question reads, if alpha and beta are the roots of 2x squared minus 3x is equals to minus 1. We are asked to find the value of Roman numerals 1, alpha squared plus beta squared. Roman numerals 2, alpha cube plus beta cube. Roman numerals 3, alpha divided by beta plus beta divided by alpha. The first thing for us to do is to identify this question is from which topic. Of course, this is from roots of quadratic equation. And for you to find roots of quadratic equation, you have to find the sum of the roots and the product of the roots. That's the first thing to do. And again, you have to check the equation that is given. If you look at this equation very well, it's not in quadratic form. We have to rearrange it to be in quadratic form. So let's look at how we can solve this. The first thing for us to do is to write down the solution now. Quadratic equation is of the form ax squared plus bx plus c equals to 0, given that a will not be equals to 0. Why? Because if a is equals to 0, it will render this equation to be linear. It will be a linear equation, not quadratic equation. And again, quadratic equation is of degree 2. The highest power is 2. So we have to rearrange this equation that was given from the question to be of this form. So we have 2x squared minus 3x equals to minus 1. This was the equation that was given to us from the question. So to rearrange this to look like this, it will be 2x squared minus 3x, then plus 1 will be equals to 0. Okay? So you realize that this quadratic form is the same as this. And from here, by comparing, our a is 2, b is minus 3, c is 1. So I can say a is 2, b is minus 3, then c is 1, respectively. Okay? So with this information, we can easily find the sum of the roots as well as the product of the roots. Okay? Sum of the roots now. Sum of the roots will be alpha plus beta, which is equals to minus b divided by a. Then we have product of the roots now. Product of the roots will be alpha times beta, which is c divided by a. So this is sum of the quadratic equation, and this is the product of the quadratic equation. So let's get the sum and the product first before we can solve alpha squared plus beta squared. Okay? Let's get the sum. Our sum, which is alpha now plus beta, is equals to minus b divided by a. From here, our b is minus 3, so we substitute. This will be minus 3 into minus into minus 3 rather, divided by a. Of course, a is 2. This is 2. Minus times minus is positive. That will be 3 divided by 2. So this is our sum. Then let's move to the product now, which is alpha times beta is c divided by a. Okay, and from here, our c is 1, then our a is 2. This will be 1 divided by 2. So we can now quickly solve this Roman numerals 1. Okay, alpha square plus beta square, we use one of the identity. So Roman numerals 1 now, we have alpha square plus beta square This is the same thing as alpha plus beta all square minus 2 alpha beta. So this is the identity for alpha square plus beta square. Okay, so we can substitute. Why? Because we know our alpha plus beta as 3 divided by 2. Then alpha times beta as half. So we can substitute. This will be alpha plus beta is 3 divided by 2 all square minus 2 into alpha times beta is half. So this will be half. Okay, so this equals to 3 square is 9. Of course, 2 square is 4 minus 2 here, 1, 2 here, 1. So we'll be left with 1 times minus 1 times 1 will be minus 1 divided by 1. So the LCM here is 4. 4 into 4 is 1 times 9. That will be 9 minus 1 into 4 is 4 times 1, 4. So this will be 9 minus 4 is 5 divided by 4. This is improper fraction. So we have to change this to mixed fraction or proper fraction. So this will be one whole number, that's 4 into 5, it will enter 1 remainder 1 divided by 4. So this will be the solution to Roman numerals 1. So let's move to Roman numerals 2. Let's permit me to click here to solve for Roman numerals 2 now. The question is given as alpha cube plus beta cube. We have to recall the identity here as well. So this alpha cube plus beta cube is the same thing as alpha plus beta bracket open alpha square plus beta square minus alpha times beta. It means if we expand this, we'll get this back. That's what it means. If you multiply that's alpha times the whole of this, then beta times the whole of this, at the end of the day, you get alpha cube plus beta cube. Okay, so we know our alpha plus beta already as 3 divided by 2. So this will be 3 divided by 2 in brackets times alpha square plus beta square is 5 over 4 from Roman numerals 1. So this will be 5 divided by 4 minus alpha times beta is half. So this will be half. We close the brackets. So from the knowledge of Bodmer's bracket first, so let's work on this. So the LCM here is 4. 4 into 4 is 1 times 5. That will be 5 minus 2 into 4 is 2. 2 into 4 means 4 divided by 2 is 2 times 1, 2. So this will be the same thing as 5 minus 2 is 3 over 4. So this will be 3 divided by 2 in bracket times 3 over 4. So this will be, we can say 3 times 3, this will be 9 divided by 2 times 4 is 8. Again, this is improper fraction. We have to change this to mixed fraction. 8 into 9. It will be 1, remainder 1 over 8. So this will be the solution to Roman numerals 2. The last but not the least is Roman numerals 3. Let's move here to solve that. Let me leave the sum and the product because I may still need it here. So Roman numerals 3 now giving us alpha divided by beta plus beta divided by alpha. So here we can find the LCM. Of course, the LCM will be alpha times beta. We now say beta into alpha times beta will be left with alpha times alpha. That will be alpha square plus. Then we now say alpha into alpha times beta will be left with beta times beta. That will be beta square. So we have beta square. This is the same thing as, remember, from Roman numerals 1, we know that alpha square plus beta square is the same thing as 5 over 4. So this will be 5 over 4 divided by, because this sign is divided by, and we know that alpha times beta is half. So divided by a half. So this is the same thing as 5 divided by 4. This division sign, we will change this to multiplication. Our numerator will become our denominator. Then our denominator will become our numerator. So this will be times 2 divided by 1. 2 here, 1. 2 into 4 is 2. We'll be left with 5 divided by 2. Again, this is improper fraction. We have to leave our answer as either mixed fraction or proper fraction. So we can say 2 into 5, it will enter 2, remainder 1 divided by 2. So the answer to this Roman numerals 3 is 2 and a half. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to my YouTube channel for more interesting videos. In my next presentation, I will solve question 3 from NECO 2024 Further Mathematics. Thank you for watching. You can follow me on TikTok and Instagram. Thank